Hello and welcome to a narrated tour of the 2013 Operation IceBridge campaign over the ice sheet, ice caps, glaciers, and sea ice of the Arctic. Here to help us know what we're seeing and tell us a little bit more about the mission are Operation IceBridge project scientist Michael Studinger and NASA sea ice scientist Nathan Kurtz. Welcome.
Thank you.
Thank you.
Okay, Michael, can you start us off and just describe what we're seeing here?
Yeah, this is a typical early morning at Thule Air Base in northern Greenland, when it's still early in the year, probably sometime in March, when the sun is low on the horizon in the morning, as you can see here in these images. And we are following the vehicle here on the taxi ramp that brings us to the airfield after we made a decision in the morning to fly. You can see that the runway is a little icy here occasionally. And also an interesting change here, you see that the runway here in Thule is white. And this is not actually snow on the runway, but the runway in Thule is actually painted with white color to keep the albedo down during the summer in order to avoid the permafrost melting there.
Excellent. And so after takeoff, there's usually some sort of a transit time, is that correct, to get to the place that you're studying?
Well, if we fly a sea ice mission, we often have half an hour or an hour to get to the sea ice north of Thule, which you can see here. But if we fly land ice mission, we often start recording pretty much right away as soon as we are allowed to get out of the seats and walk around in the aircraft.
Nice. So this is one of the early sea ice missions in the campaign. Can you tell us why is it named Cryosat? What does Cryosat have to do with what we do?
So what this mission was trying to accomplish was underfly a satellite called Cryosat, which was launched by ESA in 2010. Cryosat is a radar altimeter which measures the height of the surface above a reference level. So in this case, we're trying to measure the height of the sea ice surface above the water level. So you can see water in the video. So when Cryosat flies near water, gets a strong return from the water. It pretty much dominates what is seen by the radar. But then when Cryosat flies over rough sea ice, how rough the sea ice is, you can see ridges in the sea ice, different features in the sea ice. Cryosat responds very differently to those features. And we were trying to fly a grid pattern over the entire, it's called the footprint of Cryosat, which is up to 1.5 kilometers to cover it with measurements to see how the Cryosat radar return looks.
Sounds good. And I want to point out to everybody that the video that you're seeing right now is sped up about 3 times. So the flight is a little smoother than it appears from some of these. And throughout the course of this video, we'll play with the time quite a bit, but sometimes show it at the real pace too. And Nathan, do you care much scientifically or have much interest in the sea ice that is in these fjords and is sticking close to the coast, or are you mainly concerned about the main kind of ice packs out in the ocean?
We're mainly concerned with the ice in the main ice pack. Now there is interest in the ice in the fjords and how it interacts with the ice shelves, because sea ice around can dampen ocean waves, things like that. These are really poorly understood processes. So there is a branch of scientists who do like to study the sea ice. A lot of the sea ice studies that are done, say at NASA Goddard, are more focused on the more central pack, because that's the larger climatological feature that we want to see changing.
Moving on to the next mission, there's one here called Laxon Line. Another sea ice mission, is that right?
Yes, that's correct. And this is actually one out of the 2 most important sea ice flights that we have, since it's covering the entire Arctic Ocean from an area a little bit north of Alert all the way down to the coast of Alaska. So we get a profile over the entire Arctic Ocean there, which is a tremendous data set. And we're doing this on 2 lines. One in the north is called the Laxon Line. And we also fly back from Fairbanks along a transit or profile slightly south of it to get a second sample of the sea ice across the entire Arctic Ocean there.
So what we see in terms of the sea ice is around Greenland, the ice is very thick, and north of Canada. That's where we see the thickest ice that stays around all year. As you head towards the Alaskan coast and towards the Russian Arctic, the ice gets thinner. It's ice that only stays around one season. It's called first-year ice. So what we're doing is profiling the thick ice, because the thicker that is, the changes in the thickness of the ice determine in part how long it will stay around. Can it survive a summer melt? The thickness of the ice north of Alaska and Canada has been changing quite a bit. We've seen it decrease in thickness by almost half, whereas the thickness in the first-year ice areas hasn't been changing quite as much. But again, by getting a profile, we can learn quite a bit about the sea ice in these regions.
So we're moving in for a landing here in Fairbanks, Alaska. So is sea ice the reason why we're going all the way to Fairbanks?
Yeah, that's correct. Starting last year, we have expanded our activities from Fairbanks quite a bit, and the reason for this is because we can reach the Chukchi and Beaufort Sea from Fairbanks, which we can't do from Thule in Greenland. And those are fairly important areas for the people who live in Alaska, for the population there, also for industry like oil companies. So that's scientifically, of course, a very interesting area, but it also really impacts people working there on the sea ice or having to deal with sea ice on a daily basis.
And profiling the thickness, which IceBridge does over those regions, is very important, because it's those areas that used to be what's called multi-year ice. The ice used to stay around there all year. And in recent years, the ice has been seasonal, so it comes and goes. In the summer, it melts away. And by determining how thick it is, which IceBridge is measuring, it gives us an indication of what's happening in the climate. Why is it thinning? Why is it going away in the summer?
Excellent. And so I understand this is leaving Fairbanks. Can you tell us what's different about this image?
Yeah, when we take off in Fairbanks and fly back to Thule, because of the, I think, 5 or 7 hour time difference between Thule and Fairbanks, we actually have to take off around midnight in Fairbanks in order to land in Thule before 4 o'clock in the afternoon when they close the airport there. And that means we are flying the first almost 2.5, 3 hours in complete darkness.
Well, here we are. We're going to close out the video here with the North Pole transect. So I think we're leaving land here and heading back out to sea. So what do we have right below us right now?
So below right now is some of the thickest ice that we see in the Arctic, actually in the world, the thickest sea ice. And that's because the circulation of the Arctic Ocean is such that the ice gets pushed down towards the Greenland coast, towards Canada. And when it gets pushed down, it gets compacted, and you see those large ridges which are down below, and that makes this ice very, very thick. So it's this really thick ice that forms what's also called the multi-year ice pack. And so what we're flying here is we're flying up towards the North Pole. So we're sampling the thickest ice. We're trying to see how thick is that ice. And as we get towards the North Pole, we start to get towards the boundary of where the seasonal ice in this multi-year ice area is. And so we start to see a decrease in the thickness of the ice as we go out. And how quickly the ice thickness decreases out towards this area tells us something about how long can this ice survive, what's happening to the ice in terms of a changing climate. Because we've had submarine measurements in the past few decades, which have historically profiled quite a bit along this region near the North Pole. And there's also lots of historical interest in the North Pole region itself. There's camps, people put buoys out, lots of measurements around the actual North Pole itself. So this transect is very important because it tells us, how is the ice changing from the thickest out into that seasonal ice region.
Excellent. Well, thank you. This has been great.
Oh, thank you. Yeah.